Okay. All right, this section, we're learning how to find all of those critical points we talked about yesterday with a graphing calculator. Because there are times when you're given a polynomial and there's no way to find an integer 0. The only way you're going to be able to do it is with a graphing calculator. And sometimes the hardest part about graphing on the graphing calculator and getting all the pieces that you need is to play with your window and get the window around the graph that you need. Because if you put in a graph and you're trying to find the maximum value has to be in that window. If it's well outside the range of that window, the calculator won't be able to find it for you. So you're going to have to learn how to play with your window dimensions in order to get everything that you need inside that window that you're looking at. Okay? So everybody have a calculator, right? Put in x cubed. So y equals, you go to y equals. And you're going to go x cubed plus x squared minus 8x minus 8. And then you'll hit graph.
No, we can't see it all.
I can.
Okay, so go to zoom and go down to standard. If you go to zoom and standard, your window will be a 10 by 10.
Right.
Okay, that's what the standard window size is. And my graph looks like this. I will be able to see the maximum, but I will not be able to see the minimum. Can I see the zeros?
Yes.
Yes, and it's a cubic, and I see 3 zeros, so I know I'm good there. So what I really need to do is change my window so I can see the minimum. All right? So when you go to window, you see a bunch of different rows. X-min, X-max are the two that you're going to be caring about, and Y-min, Y-max. So thinking about your graph, what do we need to expand? The Y direction or the X direction?
Y direction.
The Y direction, right? Up or down? We need to go down with our window. So that Y-min is what we need to play with. So I'm going to go down to Y-min. I'm going to make it, I don't know, negative 20 instead of negative 10. And go back to the graph. Now can I see the minimum? Yes. Okay. So that's the hardest part about graphing these, is getting it in your window so you can actually find.
Back, right?
Yeah. The minimum's this would be a local minimum, not an absolute, because you can see the absolute minimum is going on to forever, and it's never going to stop. And there's no absolute maximum, but there is a local maximum and a local minimum. Okay. So let's find some of these things. The first thing let's find is the zeros. Okay, so you're going to go second, the blue button, and then calc, and you're going to go down to number 2, which says 0, hit enter, and somewhere on your screen, hopefully you see a flashing cursor. Okay, let's find the 0 that's the very left one. So I'm going to use my arrow, my left arrow button, and that cursor is just going to follow the curve. I need that cursor to be below the 0, okay, and it says left bound, below, that's good, hit enter. Right bound, then I need it to be above the 0. So I'm just going to use that right arrow, and then it flashes above the x-axis.
Do we need it like right?
It doesn't matter as long as it's above. And then you're going to hit enter again. And then it says guess, question mark, and you say, yep, go ahead and guess for me, calculator.
Negative 2.8.
Yep.
Yep.
Yep. And you see where it says y, mine says y e to the negative 12.
Mine says y equals 0.
Okay, mine says y equals y e to the negative 12. E is times 10 to the negative 12. I don't know if you knew that. So this says it's 1 times 10 to the negative 12. That's a bunch of zeros. That's 0.
Oh.
Okay, so if you see this and you're like, oh, it's not 0. Well, if it's e to the negative some big number, it's essentially 0. Okay, so I got negative 2.828427.
That's what I got.
Okay, let's find the next one. So we're going to go second, calc. We still want to do a 0. This time, as we follow the curve, notice that the arrow is cursor, or the cursor is flashing, and the left bound is actually going to be above. Okay, so I'm going to hit enter above, and then I'm going to use the arrow until it goes below, hit enter again, and enter as a guess. I get negative 1.
Yes.
Wait. It's still. Okay. Yeah.
You get negative 1?
Yep.
Everybody know how to do this? Okay. All right, let's find the third 0. So I'm going to go second, calc, 0. And I'm going to take my cursor till it's below the x-axis, just a little bit below.
A left bound or right bound?
That's left bound. And then right bound's going to be above. And I get 2.828427, positive.
We're doing this one.
We started left and worked our way right, but that's okay.
We're doing this one.
Okay, so everybody clear on how to find the zeros? Okay, so now let's find the maximum. And the maximum and minimum will help you. Number one, if they ask for the maximum, that will help you because you'll be able to answer it. But also if they ask for intervals where the function is increasing or decreasing. Okay, because on our graph, it's increasing from negative infinity on the x, because your intervals are always x, negative infinity to whatever the x value is of the maximum. Then it's decreasing from the x value of the maximum to the x value of the minimum. Then it's increasing again to infinity from the x value of the minimum on to forever. Right? So it helps us to find the maximum and minimum because then we can answer where functions are increasing or decreasing. Okay? So let's go second, calc. We go down to maximum. Okay? So I'm going to take my cursor and I'm going to get it to the left of where my maximum looks. So mine's flashing like right here. There's no perfect place, as long as it's not on the maximum, somewhere to the left. Hit enter. Now I'm going to move my cursor to the right until it's past the maximum, somewhere past. Hit enter. Guess.
Negative 2.00000.
Yeah, so negative 2. The actual coordinate of the maximum is negative 2 comma 4. Okay? If they ask you the value of the maximum, you're going to say 4, because it's the y value. But now I can tell you this function is increasing from negative infinity to negative 2.
Yep.
Okay? And once I find the minimum, I'll find the second part of where it's increasing. Okay? So let's find the minimum. So we go second, calc. We go down to minimum. We go until it's just before, like this, before the minimum. Hit enter. Scroll till it's after the minimum. Enter. Guess. Yes. 1.3, so 4/3. Okay. And then negative 14.51852. So my minimum happens at negative 14.51852. My function is decreasing from negative 2 to 4/3. And it's increasing from negative infinity to negative 2, union with 4/3 to infinity.
But your minimum and maximum would be your y.
Mm-hmm.
Okay. All right, I'm going to write that down. Perfect.
Okay. Does that help?
Yeah.
Okay. So let's see if there's anything else in this section that we need to talk about. One other thing you can do with the graphing calculator is find your y-intercept. And that you're going to go to value. Value. So that's number one. Hit value. X equals what for the y-intercept? What's the value of x anywhere on the y-axis?
0.
0. So that's the value you want. You're going to put 0 in, hit enter. It tells me that the y-intercept is negative 8. Does everybody see that? So you can use the graphing calculator to find your y-intercept as well. We could have also figured out the y-intercept looking at the function, right? Because the function, the constant of the function was negative 8. So we could have figured that out pretty easily with algebra. But if you want to use the graphing calculator to find it, that's how you do it. Okay, let's go through the textbook check. Okay, so to find the x-intercepts of a polynomial function using a graphing calculator, you press second trace, then scroll down to 0. The graph below has an absolute maximum and a local maximum. True. Its absolute maximum happens here, but if I had just this piece in my window, I could find a local. Yep. When you press the zoom button and the z standard, which I think was number 6, the dimensions are negative 10 to 10 for both axes. Question 4. For the graph above, you would be able to find the absolute maximum in the standard window. False, because the absolute maximum happens at 110, In order for it to be in your window, the standard window is -10 to 10. You'd have to have it like to be 120 to find it. So that's false. And then the last question, the video in this section is by James Souza, and that's true. Okay. Questions on any of this, or do you have any questions on yesterday's assignment on WebWork?
Will you show me how?
You can watch the video that I recorded yesterday. And then if you have questions, ask me. Okay.